Hello and welcome back to another episode of Maths with Mr. Mitchell. Today we're going to look at how we can use differentiation and equations of straight lines to be able to find the equation of a tangent at a particular point on a function. Now, it's really important to recognize that the function we're looking at is an unfamiliar function. And it's different to at IGCSE level that we don't necessarily need to recognize what that function looks like. So before we go into tackling this problem, when we want to find the equation of a tangent at a particular point, there's three steps that we should be looking to follow. And those three steps are, first step is to always find the derivative of the function. Second step is to find and then calculate the gradient of the tangent using the derivative function at that particular point that we're given. And the third step is to then find the equation of the tangent using the straight line formula of y equals mx plus c. Now, before we go into finding the derivative of g of x, it's important to recognize that often people make this careless mistake. If we said that g of x was in fact 3 over x squared, well, sometimes people say that the derivative of that function would just be 3 over, and I take the derivative of this x squared, which is just 2x. That is not correct thinking. You can't approach it in that manner. So the first thing you should do when finding the derivative of such a function where the x is on the denominator is bring that x up to the numerator and write with negative powers. So we have g of x equals 3 over x squared plus 4x. So I can rewrite that as 3x to the power of minus 2 plus 4x. Okay, so now what I want to do is find the derivative of that rewritten function of g of x. So the derivative of g of x will be 3 times by minus 2, so bring the power down to the coefficient of x. So 3 times minus 2 is minus 6, x, and decrease the power by 1. So minus 2 minus 1 is minus 3. And then we've got the derivative of that last term of plus 4x is just plus 4. Okay, so that's the first step done. Right. The second step we need to look at is to find the gradient of the tangent when x equals 1. And so to find the gradient of the tangent at x equals 1, I just simply substitute into my derivative function. So just minus 6 times by 1 to the power of minus 3 plus 4. And at this stage, you could use your calculator to get an answer, or you can solve it kind of mentally. 1 to any power is just going to be 1. So 1 to the power of minus 3 is still going to be 1. 1 times minus 6 is minus 6 plus 4 gives me a value of minus 2. So that means the gradient of my tangent at the point 1, 7 is minus 2. And now for the third step. The third step, I'm going to use y equals mx plus c. We know our gradient is minus 2 from previous step 2. And we know the point that we're looking at is in fact 1, 7. Right, so let's substitute into my gradient y-intercept formula. We have 7 equals minus 2 times 1 plus c. Rearranging that, we get 7 plus 2 equals c, so 9 equals c. And hence, the equation of my tangent, so the equation of the tangent at the point 1, 7 is y equals minus 2x plus 9. And if we wanted to then have a look at the function drawn, we can see we've got the blue unfamiliar function at the point 1, 7 is here, and we've got our tangent or at that point, and obviously it is a negative straight line, and obviously the equation that we found matches the actual graphical solution. So thank you again for joining in. Have a good day. Best of luck.